I'm Shora, and my registration number is 19BCE1704. So in compiler, I have chosen the topic Runtime Compilation for Multiprocessors. What actually is a compiler? As we all know, the computer understands the binary language, which is zeros and ones, and what we write in a programming languages is simply English using some keywords. So this needs to be converted into the machine language that can be understood by the computers. So this is what this job is done by the compiler. So a compiler is a special program that processes statements written in any particular programming language and turns them into machine language or code that the computer's processor uses. So typically a programmer writes languages in a like in Pascal or C one line at a time by using an editor like Notepad++, Eclipse, Save C++, etc. So when executing, the compiler first analyzes what the program has been written, then checks if it is syntactically correct or not, one after the other, then in more successive stages or passes builds the output code or what is to be printed to the screens, making sure that the statements referred to other statements are referred correctly in the final code. So by using this diagram, I've tried to explain the multiprocessor in simple words. So I've named this girl as Joy. This one is Mira. So Joy is a girl which she was using. She was doing an online classes at that time. Her laptop got stuck in between and was not running and crashed. So she went to a store to buy a new laptop, where the Mira introduces her to laptops which have dual core and quad core. She was interested in knowing more about it. So dual core and quad core means like from the word dual we know that it means two. That is, it has twice the abilities or twice the efficiency as as one processor. And quad core is also the same. It is 4 times efficient or 4 times better than the single processor. It uses 4 microprocessors or it uses 2 microprocessors, as I can state that. All of these when used together, all these processors when used together are known as multiprocessors in a computer. So now we come to a more realistic or I can say a standard definition or technical definition of what is a multiprocessor. So multiprocessor is a computer system with 2 or more central processing unit, CPUs, which share a common access to the RAM. So the main objective of using a multiprocessor, as we have seen before in the case of Joy, is to boost up the system's execution speed, with other objectives being fault tolerance and application matching. As shown in this picture, we have 1, 2, 3, 4, 5, 6, 7, and 8 CPUs which are sharing the memory together and are inside a computer. So this means that it is 8 times faster, 8 times more efficient, and 8 times more better than a uniprocessor. So now I have pinpointed the benefits of using a multiprocessor, that it enhances the performance. Multiple applications can be used. Like at the time of our online classes, we are being connected to the Teams app. 10 tabs are open in the Google. We're also using the Word file and also making up PPTs. All these stuffs are being done at the same time. So multiprocessors support multiple applications being used at the same time. Multitasking inside an application, high throughput and responsiveness, hardware sharing among the CPUs. Like here we can see that the memory is being shared by these 8 CPUs. Now we come to the applications of the multiprocessor system. So such systems are being used where we require high computations and exact results. Wherever we need accuracy and precision, we use multiprocessor systems. Like in the satellite control, which sees how we have to launch the satellite and all those work are being done. All of this needs a very high computation. It requires supercomputer and a highly efficient system. All of this is being done by the multiprocessor system. In the weather forecasting, we have to predict the floods, volcanoes, earthquakes, all those things. So all of this stuff needs to be very precise and accurate, as it is very important and is the main key point of the weather forecasting system. So this also uses the multiprocessor system in it. Next, we have the compilation runtime. My text has been hidden. Yeah. So in many algorithms, data are produced or being input during a program's initialization, which plays a major role in determining the nature of the subsequent computation. So in any computation, the importance is of the input that we are giving to it. When the data structures that define a computation have been initialized and a pre-processing phase follows. So first we define all the data structures, and the vital elements of the strategy are used by the rest of the algorithm, which has been determined by the pre-processing phase. To effectively exploit many multiprocessor architectures, exploitation means to use it efficiently, all its features. So we may also have to carry out runtime pre-processing. So this is what I'm talking about and is known as the runtime compilation. So the purpose of the runtime compilation is not to determine which computations are to be performed, but it determines how a multiprocessor machine will schedule all of this. It does a pre-planning to it. So it will schedule an algorithm's work and will map all the data structures and how the data is moving in it within the multiprocessor and how it is being scheduled or pre-planned. Runtime compilation may be needed to identify and exploit concurrency. So the runtime processing plays an important role in exploiting multiprocessor architectures. To use the multiprocessors and its benefiting features, we need to know how we have to architecture them and how we have to compile them in the runtime. Examples of such pre-processing includes runtime parallelization. As we know, runtime parallelization means running different systems, different apps, different things at the same time. Parallel computing, runtime aggregation, and scheduling of remote distributed array accesses, and execution time and data and workload partitioning. So the next I'll be briefing about the runtime parallelization. Runtime parallelization is a very obvious form of a multiprocessor runtime compilation. All of this is trying to use multiple things at the same time so that our time has been consumed less, our effectiveness of it has been more and more advantageous to us. So parallelization is carried out during compilation and it is necessarily conservative. If a compiler cannot figure out how to generate a correct parallelizing loop transformation, loop iterations have to be performed sequentially. So sequentially we do loop iterations so that we know how to arrange all the things. Many loop nests defy compiler time parallelization and depends upon certain patterns. So whenever the loop is nested at times, we cannot iterate it or use it efficiently, and it may depend on other things like determining of variables, initialization of arrays, which has been all of this is done at the time of the program execution. So one way of carrying out runtime parallelization is to analyze the inter-iteration dependency. Inter-iteration dependency means that some loops can be iterated very easily. On the other side, we get to know that the some loops are dependent on other things like variables or array declarations and cannot be iterated at that time. So they must be so we all must know that the inter-iteration dependency pattern in a loop nest so that we can identify the wave fronts of a concurrently executable loop iterations. Here the compiler transforms the code into two separate code segments. So the first code segment is known as the inspector. So here is a keyword which is the inspector. It finds the set of independent loop iterations in the whole program, all the independent loop iterations which can be done. The second code segment is the executor, which carries out all the scheduled work which is pre-planned. The runtime parallelization transformations have been implemented in a prototype compiler targeted at shared memory device machines. Runtime compilation also handles a subset of possible times of runtime parallelization, which is the parallel computing. Or transformations only apply to loop nest in which inter-iteration dependencies do not depend on the results of computations carried out within the loop nest. So, which is not dependent on the nested loops. So this was all, and thank you for watching my video. Have a great day.